Example number 4, solving a combination problem by considering cases. Dun, dun, dun. Whenever we see cases, we're thinking we got to add or subtract. Okay. So we're going to find the number of potential ways at each level, and then we're going to add all of those options together. Or I'm going to show you a method B that will help you arrive at the same answer. So there are two methods. A, building a case. Okay, so this is always when we add. Let's launch into the question itself. So a planning committee is formed from a school-wide Earth Day program. There are 13 volunteers. We have 8 teachers and 5 students. How many ways can the principal choose a 4-person committee with at least 1 teacher? Whenever we see at least or the words at most, kind of giving you the impression that there are different options available, we have to consider cases. So the first case is at least 1 teacher, so the first one is 1 teacher. And it's a 4-person committee, so then we have 3 students. Case 2 is 2 teachers, 2 students. Third one is 3 teachers, 1 student. And the last option is 4 teachers, 0 students. So 1 teacher, we know that there are 8 teachers to choose from, and there are 5 students to choose from. So for the teacher spot, we want to multiply these two options together. So we're going to say 8 teachers, and we want to choose 1 of them. And we want to multiply that by 5 students to pick from, and we want to choose 3. I'm not going to evaluate these quite yet. We'll do it all right at the end because it's a little bit more efficient. So we have 2 spots here, teachers and students. So 8 choose 2 teachers, and then 5 choose 2 students. We have 8 choose 3 teachers, and we have 5 students, and we want to choose 1 of them. And last but not least, we have 8 choose 4 teachers, 5 choose 0 students. Now this is just going to end up being 1, so we don't actually need to, but it just kind of follows the pattern really nicely. So I'm going to say 8, we're just going to start with this one and just go down. 8 choose 1 times, actually I want to quit that, times 5 choose 3, and we get 80. Now new one, 8 choose 2 times 5 choose 2. We're going to get 280. We have 8 choose 3 times 5. Oh, no, 5 choose 1. We also get 280. Interesting. Now, I'm going to ask you a leading question. I wonder if there is a pattern with specific combinations. I wonder if it's the same with permutation. So what's the relationship between 8 choose 1, and 8 choose 7. So we get 8, the final one is going to be 8 choose 4 times 5 choose 0. Again, I didn't need to write that, but it just follows the pattern nicely, and we get 70. So then, at the end, we need to add up all the cases. So 80 plus 280 plus 280 plus 70. Okay, that's just taking the answers here. And I get 710. It's like I've done this before. I'm going to show you the other method because it's way faster, but conceptually it's more difficult. Oh, sorry. B. So what we want is the total number of possible committees. And we want to subtract when there are no teachers. Because it's so close. This one actually is more, the first one is actually more work because we have to say at least one teacher. So it's, you know, you have to have 1 teacher, 2 teachers, 3 teachers, 4 teachers. But in doing it this way, conceptually it's harder because there are more things to consider, but you take the total number of possibilities and you subtract the number of committees where 0 teachers are involved. So, we're going to say 13 choose 4. Why 13? Because there are 13 volunteers. So we're not going to take into consideration teachers or students. We're just going to say the total number of committees based on this group of people. So we would say 13 people to choose from, and we choose 4. And we are going to subtract the number with 0 teachers. So I'm going to say 8 teachers choose 0. Remember, that's just 1. Times 5 students, and we want to choose 4 of them. When I do that into my calculator, so 13 choose 4 minus 8 choose 0 times 5 choose 4 equals, look at that, it's 710, just like my other answer. Okay, if you're feeling unsure and shaky, what I want you guys to do is the building of cases, because that's way easier. But if you're feeling really good about this this concept, you can try this one out. For the first little bit, what I would do is if I think I can use this total number of possibilities minus one specific case, do both of them and see if you get the same answer. Because if you get the same answer, then you know that you've done it right.